Section 5.1, example 2, writing the equation of a quadratic function from the graph. Write an equation for the quadratic function g in the figure below as a transformation of f of x squared, then expand the formula in simplified terms to write the equation in general form. So let's kind of talk about this. What they're talking about here in transformation, this was back in the previous chapter where we learned that a parabola f of x is equal to a times x minus h squared plus k. We were able to shift this h units to the left or right, k units up or down. A kind of told us a couple of different things, whether it reflected about the x-axis or whether it was like a vertical stretch, horizontal stretch, a couple of different things. But here, what they wanted in is general form. General form is going to be y is equal to ax squared plus bx plus c. So the form of a regular quadratic function. So let's see how we could do that. So first, we're going to look at a transformation of f. They wanted this named g of x. So we'll call this g of x is equal to a times our x minus h squared plus k. And again, with this, what we're looking at is we have our regular parabola here, as you guys might remember. Shifting just this vertex down 1, 2, 3 units and left 1, 2 units. We're actually just shifting the vertex there. So we could start off with that. Our vertex is kind of just like what we're going to use to kind of shift things left and right, up and down. And I think that's a really great start off point. So let's say g of x is equal to a. We don't know exactly what a is yet. X is going to be there. Square is going to be there. And we have our k right here. So h, our x minus h, we're shifting left and right with h. So we moved from our origin, we moved 1, 2 units to the left. So to -2, what we're doing is looking at the opposite of -2, so +2. This is going to be a +2 in here. And k units up or down. Here's our vertex here. We moved 1, 2, 3 units down. So down is going to be minus and then 3 units. All right, so we have everything so far except for A. We could literally pick any other point other than the vertex, because the vertex is always going to give us that input versus the output. A, we could use any other point on the graph. So if you want, you could use this point here. I personally don't recommend it because I don't know. It kind of looks like it might be half, but I don't want to say that it is half. We see this point right here clearly. We see this other point over here clearly as well. So what I want to do is use one of these 2 points because we could clearly see that it meets right there in those intersections of our grids. So I'm going to use this point when x is 0, y is -1. And we're going to plug those points into this equation right here. G of x. So everywhere we see an x, or let's just rewrite the equation. X plus 2 squared minus 3. Everywhere we see an x, we're going to plug a 0 in. So 0 here. See another x here, so we're plugging in a 0 there. And lastly, y is equal to -1. So y, we're just going to set this equal to -1. And there we go. This is the equation that we're solving A for. Over here, if you want, you could erase this part just so it doesn't get in the way. And let's get started with that. So doing a little bit of like solving for A here. This is a term that has A in it. So what I'm going to do is get this 3 and add it to both sides. So +3 here, +3 here. At the same time, I'm going to add these two together. 0 plus 2 is 2. So we have a times 2 squared is equal to these 3 subtract out. So we're left with 2. Next, I'm going to square those two. 2 squared is 4, so we have a times 4 is equal to 2. Lastly, to get a by itself, we're going to divide both sides by 4, leaving us with a is equal to 2 over 4. 2 divided by 2 is 1. 4 divided by 2 is 2. So what we actually have is a is equal to 1/2. And now that we know what a is, we could plug it back into this equation here and get our function in vertex form. G of x is equal to a, which we just found out was 1/2, x plus 2 squared minus 3. And almost highlighted that part. So this is our function in vertex form, but what they actually wanted was our function in general form. So what we're going to do here is expand this one to get it in ax squared plus bx plus c. So general form. And let's do that. So here, if you don't see it right away, we're going to square that part. 1 over 2. Then we have our x plus 2 times x plus 2. It's a binomial being squared, so we have to write it in that way. And now we could expand that middle part. So expanding this too. Still going to keep it in parentheses. So x times x is x squared. X times 2 is going to be plus 2x. 2 times x is going to be plus 2x. 2 times 2 is going to be 4, so plus 4. And lastly, we're subtracting 3 from the end. Let's combine like terms inside of these parentheses. It looks like we could combine those two. 1 over 2, we have x squared. 2 plus 2 is 4, so plus 4x. Plus 4 minus 3. Before we finish, we have to expand, distribute the 1/2 through those 3 terms. So 1/2 x squared. Looking at this part, 1/2 times 4. So 4x, that would be like 4x divided by 2, which would give us 2x. So plus 2x. Then we have 1/2 times 4. Would be like 4 times 1/2, or 4 divided by 2, or just 2. And lastly, minus 3. And now to combine like terms, I see that these two we could combine. So that leaves us with 1/2 x squared plus 2x. And lastly, 2 minus 3 gives us -1. And there we go. That's our function. G of x is equal to 1/2 x squared plus 2x minus 1. And if you have any questions, please feel free to ask. Otherwise, bye.